Ba-ba-ba. Good afternoon, I'm Alex, and it's time to do some more Advent of Code. Uh, to give a brief overview of what we're doing, we're solving the Advent of Code challenges every day on the day, and we're doing it in Livebook, which is the Elixir notebook implementation. So think of this as maybe Jupyter, but with less features, but much saner semantics overall. And, well, it's much nicer to use if you're running it just for yourself. So far, we've gotten launched out of a trebuchet on day 1, then played a game with colored cubes on day 2, and then yesterday we had to fix a gondola machine. I think the overall story arc is that we're trying to fix the snow machine, so we've been slowly making our way up a mountain. Yesterday's problem was, well, this is supposed to represent a machine. The symbols were supposed to represent components in the machine, and we essentially had to find the numbers that are adjacent to the components. We did this with some fairly intricate parsing. Then once the parsing was done, we could easily just grab all of the components and sum them up or multiply them as required. Yeah, and that was it for yesterday. So now let's move on to the next day, day 4. What do they have in store for us? Scratch cards. So the gondola takes you up. Oh, this is actually a nice surprise. I was really expecting the gondola to just leave without us and then us having to make our way up the mountain on foot or something. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of snow island recedes below you, an entire new landmass appears above you. The gondola carries you to the surface of the new island and lurches into the station. So what, this is like a sky island of some sort? As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. But we're going to be playing Duel Masters, aren't we? Okay. Oh, hello. The elf excitedly runs over to you. How may I be of service? You ask about the water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island after all. I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat, and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to a pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Hold on. How is borrowing his boat going to help if we're on a sky island? Yeah, this... we're going to need a parachute, probably. Right, so we discovered dozens of scratch cards. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. A list of winning numbers and a list of numbers you have. You organize the information into a table, your puzzle input. So this thing, I guess. As far as the elf has been able to figure out, you have to figure out. Figure out. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. For example, so the first match makes the card worth... You have to figure out which of the numbers you have appear in the list of winning numbers. So these numbers, which are definitely not sorted, in these numbers, which are also not sorted. In the above example, card 1 has 5 winning numbers: 41, 41, 48, 83, 86, and 17. So these are the numbers we have, and these are the winning numbers. The 8 numbers you have: 83, 86, 6, 31, 17, 9, 48, and 53. Of the numbers you have, 4 of them, 48, 83, 17, and 86, are winning numbers. So is it? So 48, 48, 83 is 83, 6 is not, 17, 17, and 86, 86. And we don't have 48. No, we don't have 41. Right. This means that card 1 is worth 2 points. 1 for the first match, then doubled 3 times for each of the 3 matches after the first. So this is 2 to the nth minus 1 power. Card 2 has 2 winning numbers, 32 and 61. 32 and 61. I wonder if these numbers can be doubled, or if these numbers can occur more than once, or if they're unique. Hopefully they're unique. Card 4 has 1 winning number, so it's worth 1 point. Card 5 has no winning number, so it's worth no point. Okay, so it's 2 to the n minus 1, unless it's 0, in which case it's worth no points at all. So in this example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colorful cards. How many points are they worth in total? This seems suspiciously easy given what we had to deal with yesterday. Okay, and what's our puzzle input look like? It looks like, yeah, the 2 lists of numbers aren't particularly large, and we don't have all that many cases. Okay, so let's get cracking. New notebook. This is going to be called AoC 2023 Day 4. We're going to save this to avoid any data loss, because at some point one of these days my computer is going to crash. As always, we need as a dependency so that we can read stuff. Let's just evaluate it. Right. First section is helpers. As always, we're going to need an example input. This is where we're going to put our example. Then I want a real input. Let's just quickly copy these in so that we have them for future reference. So this is our example, and this is our real input. And then we're going to have a new section for part 1. And I'm also going to clear my clipboard because there's a weird... Oh wow, that's annoying. Oh, I guess I'm not clearing my clipboard today. There's some weird interaction between Wayland and Firefox in Livebook that sometimes causes Livebook to get stuck into a weird state if there's something in the clipboard. Anyway, back to this. So we start by reading our input, or rather by reading our example, right? We are going to split it into lines because every test input is on a separate line. String split. Yeah. This works, except we have an extra empty list at the bottom because we have an empty new line there. We could just delete the new line from the input, but instead we're going to handle it here, trim. So now we discard all of the empty stuff at the beginning and end. Okay. Next up, we don't actually care about... Next up, we technically have to parse this, but I think we can just do it in a very hacky way given how simple this all seems. So first off, we're just going to discard everything up to the colon. Right, we can just do that. We just need how many points are they worth in total. We don't actually care about the game number. So enum.map, because we're going over every line individually, then we're going to do string split. What does string split do? String split pattern. Okay, so line. This gives us a list of the card and then the actual values. Good. So we just wanted the second part of this. This isn't a great way of doing it, but yeah, let's just match here. Values. Right. Now I wonder if we can also split. It's a pattern, but I bet we can do this with a regular expression as well. String split. Pattern may be a string, list of strings, or regular expression. Okay, so we can do the splitting, we can do this, we can split on this in the same command. So for that I need this, or, well, first off, let's see if this works. Yep, this still works. And now I want to put this in a group, yep, and we want to split on either that or on this. Yes, and also a space before. Okay, so now we have everything we need. We have winners, and numbers. Let's just check that we're splitting correctly. Yeah. Right, I just want to match, do a simple string match here. I don't need to do the const thing. Winners and numbers. Yeah, all right, so we have the winning numbers and the numbers we actually have. But then we're going to split each of these on spaces and convert them to integers. So winners pipe into string.split. If I don't pass any arguments, it will just split on spaces. Yep. And then I just want to do enum.map string to integer. And this kind of worked, although, yeah, something weird happened below. So this is using Elixir's shorthand for defining inline functions. Does it the same thing for numbers? Yep, and this works. So, wait, does this actually work? It's 41, 48, 83 to 17, yep, and then 83 to 53. 83 to 53, yep, and we're not dropping any numbers at the beginning or end by mistake. Now, the funny output here is line 4. What's going on here is that, so these lists are lists of numbers, and they're fairly small numbers. And what's going on here is that Elixir is looking at the numbers and thinking that it's actually a char list, because these kind of look like ASCII chars if you squint at them hard enough. And as I'm guessing that this is the one line where we don't have a really weird value like 1 in it. Yeah, so it's 4. Is it 4? Yeah. Yeah, so this presumably looks like plausible ASCII characters, so Elixir is displaying it as a char list instead of as a list of integers, but that's fine. Okay. Now, what do we need? We need to find how many of the numbers we have are in the set of winning numbers. So clearly we need the set. Right, so let's just split this onto multiple lines. Yeah, so that it looks a bit better. because we're going to be adding to this pipeline. Okay, now just mapset.new. Is this going to work? Yes, and now we actually have the winners are a map set. Okay, for numbers, we don't actually need the numbers. What we need are the numbers that are actually part of the map set. So again, let's just split this onto multiple lines so that we can add to the pipeline. And then we just do a num.filter. Again, we're using the shorthand function syntax, and we want map one in winners. Does this work? This does indeed work. Man, this is annoying to look at. Okay, so there are 4 winners on the first card: 83, 86, 17, 48. 83, 48, 17, and 86. Yes. Card 2 has 2 winning numbers: 32 and 61. Those are presumably 32 and 61. Next one is 21 and 1. 21 and 1, yep, then it's 84, and then nothing and nothing. I can close this tab. Okay, then it's 21. Is it 21? No, it's 84. So then it's 84, and then nothing and nothing. Okay, and now really we just need the lengths of these things. So can we just pipe it into length? Yes. And now that we have the lengths, we just need to pipe this into then fn x, fn n. If n is 0, do 0, else. Is this valid syntax in Elixir? I don't remember. Let's try it out. How do you do powers in Elixir? Can you do this? It doesn't like that. I'm missing an end here. And it's refusing to compile the next block since the previous block was broken. Okay, so this is 2, 3, 4. Yeah, okay, so this is how you do powers. What happens if you do 2 to the 0? 1. What happens if you do 2 to the minus 1? 0.5. Yeah, so this computes the correct mathematical value, but not exactly what we want. So we had to do an if here. All right, so now we have the score. This isn't release numbers, this is score now. So our scores are 8, 2, 2, 1. Is this correct? 8, 2, 2, 1. Okay, and then how many points are they worth in total? So we just have to sum this up. Okay, so first off, return score. Yep, and then enum.sum. 13. All right. So this should work. And now let's just try it on the given input. 24848. 24848. That's the right answer. You have 1 gold star, and we are closer to restoring snow operations. This was suspiciously easy given what the previous few days were like. I'm now mildly worried about part 2. Okay, let's go. Part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of each card the whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win 1 copy of each of cards 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of a card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. cards 11 through 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. So this time the example goes differently. Is it the same example? 41 through 72, yep, and 83 through 11. 83 through 11. Okay, card 1 has 4 matching numbers. So you win 1 copy of each of the next 4 cards, 2, 3, 4, and 5. So now we have 2 copies of each of these. Your original card 2 has 2 matching numbers, so you win 1 copy each of cards 3 and 4. Okay. The copy of card 2 also wins 1 copy of each of cards 3 and 4. Yep, okay, so at this point we have 3 copies of 3. Now we have 4 copies of 3. How do we have 4 copies of 3? We had 1 card 3 to start with, then we got a second one from card 1, then we got a third one from card 2, then a fourth one from the copy of card 2. Okay, so we have 4 instances of card 3. 1 original and 3 copies. Have each matching number, so you win 4 copies of cards 4 and 5. Your 8 instances of card 4, 1 original and 7 copies, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, your 1 original and 13 copies have no matching numbers and win no more cards. And your 1 instance of card 6, 1 original, has no matching numbers and wins no more cards. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 of 3, 8 of 4, 14 of 5, 1 of 6. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. Process all of the original and copied scratch cards until no more scratch cards are won. Including the original set of scratch cards, how many total scratch cards do you end up with? Okay, this is not particularly bad, and given how short our input is, we only have 208 cards in total. And we ultimately only have to really do this in one pass, because we can never loop back to the start. So we're just going to look at card 1, figure out how many cards need to be duplicated, and we know we'll never make you copy a card past the end of the table. Yep. Then card 2, then we're going to store an array, or rather a tuple. No, we're going to have a map for each card number. Yes, for each of the 208 card numbers. Then we're going to process card 1, figure out how many new cards we have to insert, and then just iterate through those and add them to the map. Then we're going to do the same for 2 and then iterate through the list, adding them to the map. Then do this for 3, go through the list and add them to the map. And then, yeah, so this will be a quadratic algorithm. And quadratic is not usually nice, but we only have 200 numbers here, so like 200 times 200 is 40,000. We can absolutely process this extremely quickly. And then after we're done computing the number of cards we have at the end, we're just going to do 1/3 pass and sum them up. Okay. So let's leave part 1 as it is. And let's make part 2. We're going to copy everything we did in part 1, because this is almost what we want as a first pass anyway. And then maybe we'll deduplicate it later. Let's switch back to looking at the example here. Yep. Okay. First off, we still don't need to actually parse the card number, because these cards are in order. So we're instead just going to use with index. Yeah, we're going to do enum with index to add the index. Can I set the starting point for with index? fun or offset. Maybe a num with index 1. Okay, now this is no longer going to be a map over line, it's going to be a map over tuples of line and the index. Okay, let's not sum up at the end. Let's return the index and the score. So we have 1, 8, 2, 2, 3, 2, so on. This is how many wins we get for each card. Okay, so next up, let's make this into a map, maybe? Should this be a map? No, it doesn't need to be a map because we're going to be iterating it one element at a time. Okay, so next up, we're just going to reduce over this. And we're going to start with, we want the second version of reduce that also has an accumulator. And the accumulator starts with empty. It really shouldn't be empty, but we can make this work. Yeah. And then we have as arguments the game number, the wins for that specific game number, and our accumulator. And we're just going to return our accumulator, so this now returns an empty map. Okay, this empty accumulator here isn't quite what I want. What I want is... So what I want here is a map of 1 to 1, 2 to 1, 3 to 1, and so on. So I want a map from the game number to the number of cards for... they're called cards. So I want a map from the card number to the number of copies of that card we have. And we always start with one of each card. So here, let's do it like this. Cards equals this. We're going to split the pipeline so to make everything clearer. Then we have cards here. Yes. This was part 1, not part 2. Still runs. I'm just going to minimize this so that we don't make this mistake again. Okay, so cards. These are the string representations of the cards. Then we do the usual processing. And then here, our accumulator starts with 1 through length of cards. This gives us a list. And num.map. So I take the card number and then I return the card number and 1. Yep. And then we just collect this into a map. And let's split this over multiple lines for readability. And now if I run this, it should give us a map of 1 to 1, 2 to 1, 3 to 1, and so on up to 8, I believe. 6. Okay. Yes. All right, we have this done. All right, so now we have... So this is not called game, this is called card. So now we know that for card 1, we have 8 wins. 8 wins? That seems like too many wins. Card 1 has 4 matching numbers. Okay, we're no longer doing the power thing. We're just doing the matching numbers. So here, we don't have to do the power thing anymore, we just care about the number of matching numbers. Okay, so we have 4 wins for card 1. This means that we go through 2, 3, 4, and 5. So we update the map, we update the next 4 positions in the map, and we just increment the next 4 positions in the map. That's what we're doing. So for I in I want card through to card plus wins. Then I'm updating ACK. Actually, let's just do this with a reduce, since reduce always seems nicer to me than Elixir's for comprehension syntax. Num.reduce. So we start with accumulator, then we take the card to update, and then we're just going to do map.put ACK and this should actually be card plus 1 to card plus wins. Card plus 1s because we don't want to update our own card. Card plus 1, and we're going to add here ACK of I plus 1. And this needs an end. And this is it. So this does the whole reduce. What does it say here? What's the error? Oh, it's a tuple? Where's the error? With arity 1 enum, line 22, line 26. So 22 and then 26. So this reduce is wrong because I'm not passing an accumulator here. Okay? And it's saying it doesn't have a value for I. How can it not have a value for I? Well, let's do an IO inspect and see what I is. So I is 2, 3, 4, and eventually we get to 7. Okay, why did we get to 7? Well, actually, we can check that this worked. So it was 2, 3, 4, 5. This was for card 1. And then we have 3, 4 because we have 2 wins for card 2. Yes, and then we ignore that for a second. Card 3 has 2 matching numbers, so there should be 4, 5 somewhere here. Yeah, right, like 2, 3, 4, 5, we update those, then these are the 2 numbers for 2, then these are the 2 numbers for 3, and then there are 2 numbers for the next one. Have 1 matching number. Does card plus wins, what happens if you do, say, 5 to 4? Num to list. Oh, so it's smart enough to actually do a descending range. Alright, so if wins is greater than 0, do this whole thing. Else, just return the accumulator and don't update anything. Alright. Now, I noticed another thing here. We don't have to increment it by 1. We have to increment it by the number of cards we actually have. We actually have of that particular number. So here, it's actually incrementing by ACK plus card, I believe. I can delete this so that it doesn't confuse us. Right. And now we have 1 card, 1 instance of card 1, 2 instances of card 2. Is that correct? 2 instances of card 2. Then we need 4 of card 3. 4 of card 3, then 8 of card 4. 8 of card 4, 14 of card 5. 14 of 5, and 1 of 6. This, I remember, it was 1 of 6. Okay, and then we just have how many total scratch cards do you end up with. So now we just need to add up the values here. I feel like this didn't indent properly. Okay, then can I just do map.values? Alright, and then enum.sum. 30. Is it 30? We have 30 scratch cards, okay? And now we just change our input to the actual production input. And this is a large number. That's the right answer. You are 1 gold star closer to restoring snow operations. Oh well, this was way easier than I expected it to be. Advent of Code usually has a ramping difficulty curve where it slowly gets harder and harder. But I feel like today was much easier than the previous days. Especially it was much easier than yesterday, where we had to do some fairly, well, somewhat intricate parsing. Like the parsing here was absolutely trivial. Alright, can we refactor this a bit? Because we're definitely duplicating code between part 1 and part 2. Like all the parsing is duplicated and all of the score computation is duplicated, or rather all of the matching numbers computation is duplicate. Yeah. Let's factor this out and then we'll call it a day. So we take kind of the common part, we're going to add it as a module under helpers. Module. It has to be in a module because Elixir really doesn't like top-level functions. Let me just call this read input. Input when is input binary. We don't really need this guard here, but I like to have guards whenever possible because it stops careless mistakes later. Okay, now we paste this. And we indent it. I will screw this specific action up multiple times. Okay, so what do? We take cards are input, and then we split on the lines. Good. Then we take each card, we add an index to them. We split the winners and the numbers. We parse the numbers into an actual map set. We're not going to need the winners after this, so we'll be able to just drop that. Okay, and then score. In part 1, we need the number so that we can then raise it to the power of 2. And in part 2, we just need the number. So, yeah. Calling it score is fine, and then we return IDX and score. And we return it as a list, which is good enough for our purposes. However, we do need both of these, because in part 2, we need the length. But actually, we don't need the length because we can compute it from here, can't we? Yeah, so this is binary input. I think this is actually just what we want. And then we have to modify part 1 a bit. Okay, here. So let's just do AoC, read input. I think we can just delete everything here except for the 2 bits that are going to be different, and we're just going to comment these out for the moment. See, having a guard was helpful because I passed the Kino input here by mistake instead of actually passing a binary. Right, so this is not a binary, this should be a Kino input. Kino input. Is this going to work? Maybe? Okay. And now we have the number of winners for each line. And then here we have to do a map enum again, because we have map enum.map, sorry. We have to do an enum map because we go over every line. We don't care about the card number here, we just care about the winners. And then with the winners, we're just going to do this thing. We're just going to raise it to the power in order to compute the score. And then we just sum it all up. Yep, 24848. That was, I think, the right answer. Let's just quickly try it out with the example. 13. Was it 13? Return to Advent calendar. Let's look at 4 again. Part 1. Oh, 4848. That was the right number. Yep. Okay, and part 2, this is a slightly more involved one. So first we need winners is read input input, and I need to specify the module. Okay, don't need cards. Don't need all of this because this is what read input is doing. Then here I pass winners into reduce. Then it's 1 to length of winners. And then everything is the same. And indeed, the result did not change. Right? It's 7258152. 7258152. All right, so that's it for the refactoring. So to recap, we just went through all of the cards one by one. We basically chopped off the first bit because we don't care about it, and we just inferred the card number based on its position in the list. Then we took the second part, split it in half on the pipe character, then split the string on spaces, converted everything to integers, turned the first list into a set, counted how many elements in the second list appear in the first list. This is what our helper module does. And then for part 1, we just raise the number of winners on each card to the power of 2, taking into account the 0 case, and then sum this all up. And for part 2, we go through their little algorithm of increasing the number of cards. And the only really tricky bit is that we have to, when we double our cards, we don't actually double them. We add the number of copies of the current card we have to all of the subsequent cards up to the number of wins. Yeah. And the other tricky bit was that Elixir ranges can actually go down as well as up. So if card plus wins is less than card plus 1, that would cause a bug. So we had to check that wins is greater than 0. And that's it for day 2. For day 4. Out of curiosity, how does the leaderboard look like these days? Not the leaderboard, the stats. Yeah. Oh wow, people are definitely dropping off. But we're among the 12,000 or so who actually finished part 4. So good for us. This number will increase later, but yeah, let's see if we can get to the very top. Okay, thank you for watching and see you tomorrow probably. Bye bye.